This is the real inverse variation. Today we are doing solving problems involving inverse variation. So let's take a comparison. With direct variation, y is equal to kx, and with inverse, and as one quantity increases, the other quantity increases. Yes, question? I just said that a couple times. Okay? As one quantity increases, so does the other. So for instance, if the price goes up, then my profits go up, right? Yes. That would be an inverse relationship. Here's what it looks like in the graph. In an inverse variation, however, it looks like this. You need these notes. Make sure you're writing them. Y equals kx. So in an inverse variation, it looks like this. Now, situationally, what happens is as one quantity increases, the other decreases. Let me give you a situation. For instance, as the price goes up, my sales will go down. If it's more expensive, less people are going to buy it. It knocks people out of the market. Does that make sense? So this is what this would look like. It's y equals k over x. And it kind of depends on the situation you create. In a graph, here's what it's going to look like. It's going to start really high and finish low. Want me to pause the recording so you can write notes? Yes. Remind me to start it up. Okay, so here we go. So let's determine whether it's direct variation, inverse variation, or neither. Number one, let's go with Patrick. Is it direct variation, inverse variation, or neither?
It's direct variation.
Yes, that is correct. Number two, Lucas Malou.
Neither?
Well, let's see. Let's get the y alone, and you make the judgment.
Correct.
What? Get the y alone. What do I have to do? What do I have to do to get the y alone?
You subtract x.
No. Next to means multiplication. What's the inverse? If it's multiplication, what's the inverse operation? Division. Okay? This is a problem at the end of your algebra year, that you don't know the opposite of multiplication. Okay? Y equals 7 over x. Okay, next. Is that direct, or is it inverse, or is it neither, Lucas?
Inverse.
It's inverse variation. Good. You should be writing these down, taking samples. Okay, next one. Let's go, Michael.
Inverse.
Get the y alone.
Number 3. Neither.
Subtract 3. Negative y equals x minus 3. Divide by negative 1. Divide by negative 1. It equals y equals negative x plus 3. So is that, what did you say? Neither. That's correct. You got to get the y alone before you can determine. Okay, next one. Number 4. Yes.
It's an inverse because 10 would be k, and for an inverse it's y equals k over x.
Yeah, it's really 10 divided by x, so that makes it an inverse variation. Let's go Lucas Ween. Number 5. Neither. It's not y equals kx, and it's not y equals k over x. Number 6, Lucas Malou.
It would be inverse.
Get the y alone and make the judgment. What do I need to do? What's the inverse? Honey, thank you. Multiply by what you want to get rid of. Yes. And so what do we get?
We get y equals 3x.
And what is it?
Direct.
Direct variation. Good. Okay, next one. Now the way we're going to see this, it's going to come to us like this. Y varies inversely. Right there I do y equals what?
K over X.
K over x. Y varies inversely with x. This is how you write it. Use the given values to write the equation. My ending part should be a y and an equation with y in terms of x. So step 1, what would I do? Patrick.
So you have to do. Okay, so first you need to find K. So you would do 4 is equal to K over 12, and
Okay.
then you multiply. Yeah, so you multiply both sides by 12. Then you get K is equal to 48,
And now what do I do with that?
and Y is equal to 48 over X.
Y equals, because it says inversely, y equals 48 over x. If it said directly, then we would write y equals 48x. Does that make sense? Okay, am I done? Do I have to input anything? There's no more data to input. Okay, pause the recording and you guys do number 2.